Hi, everybody. Let's get started. So this is week number, well, actually, let me bring it up. What week are we in? I think we're in week number 4. Let's see. All right. So let me share the screen with you. Let's see, let's do this one here. Okay. So I got the calendar in front of me here. We are now, we are in week 4, and we're working on Scheme, Lisp. I'm going to show you a few things about Scheme and Lisp today. I'm also going to show you a few things about Prolog, which is week 5's assignment. And I will also introduce a few things about week 6 and make your life easier. So let's start with Scheme. At the end of this chat session, I'll ask for questions about the midterm, but we do have the midterm this week as well. But I'll wait till the end because some people might show up, or you might think of a question while I'm talking. Who knows? So I'll break at the end of the session for that. Okay, so week 4, we're talking about Scheme. And the Scheme assignment, I've gotten a lot of questions on it, so I wanted to provide a little bit more information. Just to get you started with this. The Scheme assignments, let me switch my share for a second. Let's see if I can find Scheme. Here it is. Okay, so you've got to write 7 functions. And in a video I mentioned wrapping, which meant you write a function that calls a function. I realized that some people didn't understand what that meant, and then other people are totally taking this in the wrong direction. So I thought I would kind of do some clarifications. I'm going to do number 1 for you. There is a binomial coefficient function. So if you were going to write a wrapper, you'd write a define, and in the define, you would define the binomial that already exists. You just run the binomial. So I'll let you figure out how to do that, but I prefer you would actually write. There's a mod function too. I would prefer you would actually write the function. I give you the function format in the question here. This one happens to be one of the more difficult questions, which is number 1. Some of the other ones you could probably figure out on your own, like add binary. Maybe binary to decimal is pretty easy too. But feel free to use built-in functions inside of the functions if you'd like, which means you write a function that calls a function. If you need help doing that, send me an email message. I can send you a wrapper prototype. But I prefer you do it the manual way, which is this way. So you can download and install Racket or Scheme on your computer. Or you could, and let me just copy this here for a second. I'm going to paste it into a text window. You can use an online Scheme interpreter. So let me show you that actually. Just copy this here, stop the share, and let me see if I can find my Scheme interpreter. Not that window. Here we go. Here we go. So we'll go back to Zoom. Actually, let's do it this way. Hold on 1 second. I'm going to attempt to show you a couple things here. All right. Let's see. So I'm going to flip to a text file to give you a URL. So you can pause the video if you want later on, or copy and paste this. What I did is just did a Google search. What I'm showing you right here in the URL, I also have the answer to one of these questions up here. All the HTTPs, /repl.it.ripple. I got that actually just by doing a simple Google search. So if you didn't catch this URL, I'm going to show you how to get there right now, actually. So I'm going to share another screen with you, which is my web browser. All right, to get here, Let me just do this real quick here because I don't want to retype. Copy. Okay. So I just Googled online scheme interpreter. Online scheme interpreter. And the first one that comes up is the repel.it. I think it's an Italian site. If you press that button there, it'll take you to the website. The website kind of looks like this. There's a little window on the left. There's a window on the right. You can cut and paste out of here like I just did a few minutes ago. And so if you click on examples, which is right here, not sure what to do, run some examples. If you click on examples, you'll see that there are some simple and there are some more complex examples in the window here. So you can run print hello world. You can run, print, so what is your name? Print hello read I to get the input in. Here's a Fibonacci. These are the functions that you're writing. So for question number 1, I'll let you work with that. I'm going to paste it back in here though. This is a good answer for question number 1. Question number 1 wanted you to write a function called binomial that takes on a coefficient n and k. Okay, so binomial is the name of this function. So you use the keyword define. So if you put in define, and then you put in like mod, my mod, and then down here you put mod 1. So this is just the execution of the code. So if k is equal to 0, return 1. If k is equal to n, then return 1. Otherwise, you're going to add together the binomial n minus 1, and then you're going to send, this is a recursive call to the function, and you're going to send it k, because k doesn't change. And then you're going to have the binomial n minus 1, k minus 1, et cetera, and so forth. If you look at the assignment description, you'll see that this is spelled out for you. And then when you run the function, you're going to run it with these test cases, which is in the assignment. So if I press the run button up here in my interpreter, I get 35, because 35 is actually this last one. So I'm going to take these guys out and show you real quick here. Cut. The interpreter doesn't really, it gives you line by line, but the output was going to replace. So if I do the binomial 4, 4, 0, I get 1. If I do 8, 8, I get 1. The other one, I think it's the last one we want. It's going to give us the paste. We get 7, 4, we get 35. Because 1, what was the first one here? 4, 0, it's 0, so we're going to return 1. 8, 8, well, they're the same, we're going to return 1. And this is the recursive case that's going on here. So we add the binomials for each one of them together, and we're going to get 35 out of that. So we see the answer over here. So what do you do for the assignment? Well, you do this. Just copy it. And then don't save it online. If you want to, you can, but copy it, stick it in the Word file or stick it in a text file, and then there's your answer for number 1. There it is. If you look at some of the example, and you can obviously look at this recording, copy the code. You can turn this in for assignment number 1, assignment number 3, question number 1. That works just fine. Or actually, I'm sorry, it's programming assignment number 3. So you can turn this in as your answer. Tons of people have been Googling the internet and finding really bad answers. If you do Google the internet and you find some answers instead of writing it yourself, because I don't really expect you to learn scheme in a couple weeks here, especially in an accelerated 8-week course, try to at least understand what it is you're doing and then test it to see if it actually works before you turn it in. I've seen a lot of plagiarized answers with bad answers, and I don't want you to walk away from this class thinking that this code would have worked. At least do your due diligence to see if the answer is actually, the code actually runs and the answer actually works. And you may notice with this online, this is scheme, this is not racket. but this is scheme code. The same code works in Racket, but you'd have to define Racket above if you're using the Racket interpreter. So you might want to just use this one. This is the Viva scheme interpreter online. It's the same as it takes the same syntax as Racket. Before I continue on to the next assignment, do we have any questions about the assignment number 3? From anyone online? Because I'm going to switch over to number 4 next. Nope. All right. And, you know, to write a wrapper, you just define another function that calls another function. And actually, that's defined in the video. Actually, if you watch the video on the scheme, it shows you how to do that.
Professor, I have a question.
Yes.
Like, do we need to submit the output as well in the assignment?
No, because the output's given for you in the test cases.
Okay.
I don't need to see the output. All I need to do is see the functions. 7 functions, just cut and paste them, stick them in a text file, or stick them in the assignment submission area or in a Word file. Some people have taken screenshots of the output. That's a little overkill. If you want to do that, you can, but you don't have to. If the function's written correctly, I can get my own output. The output is for you to test with to see if the function's correct. About more than 70% of the functions you'll find online are not correct. So if you test them, you'll figure that out. There's a lot of garbage. Everything, you know, I'm a huge fan of the internet. However, there's a lot of garbage on the internet, and people find this garbage. They cut and paste it, they turn it in, and you know, it's like, wow, that's a bad answer. But it's like all over the place, especially in that those coding websites that like Stack Overflow and stuff. There's a bunch of garbage out there. So at least make sure the function works before you turn it in as your assignment. And I'm not talking to you guys in particular, I'm talking to the people who have a tendency to plagiarize. So. And this assignment is all over the internet because it's a great assignment, and it's been used over and over again to show people how, to give people an introduction to scheme, which is why there's so much cheating that goes on with it. But, and yes, to Google answers to a programming assignment is cheating, by the way. Okay, on that note, let's switch to a more positive note. All right, so no more questions about scheme. If you go through that website I just showed you, and here, let me just do it for those people who are interested. Let's just bring up that text file one more time here. The link is here. Type that in or just Google it. This is the question number 1. This is the answer to question number 1. You don't have to turn in all the test cases. You can just give me this code, or you can just give me that code up there. That works fine too. But some people had questions about how to run the functions. This is how you run the functions. So that is the function. These are how you run the function. Okay, and on that note, there's the URL to get to the assignment. I probably should leave this intact here, because now we're going to talk about Prolog. If you do have a question about scheme, don't worry, you can save it up, ask me at the end as well. So Prolog is assignment, week 4, assignment number 3 is the scheme assignment. You're writing those 7 functions, you're going to turn it in. Some people have turned it in already, which is great. In assignment number 4, you're going to be working with a cool little language called Prolog. And you have the same options. You can use it online, download and install the SWI Prolog compiler, install it on your computer, or you can use an online Prolog compiler. And I put the link for you right here, actually, which is called swish.swi Prolog. If you click on there, and I've got it opened up already, so let me stop the share here and open up the Prolog. Let's see if I can find Prolog. Is this one? It's not Prolog. Hold on 1 second. Let me open up Prolog. I can get rid of this one. Oops, hold on 1 second. Leave this one. Got too many things opened up. Hold on 1 moment. Getting there. You know what? I might just need to click on the. I might just need to click on it. All right, so let me open it up fresh for you. Somehow I closed it. Oh, no, I got it. I got it. Let's see. Okay, there we go. All right, I think I'm sharing my screen now for Prolog. And when you first open it up, you don't have anything on the screen. You have, if you click on examples, when you first open it up, this is all going to be blank. If you click on examples, example programs, you have Prolog tutorials, you have Swish tutorials. Go ahead and explore this. The purpose of doing Scheme as well as Prolog is to get you familiar with the IDEs as well as the languages themselves. You have some videos in the class to watch on them, but you also have a little exploration that goes on in the compiler itself. And you're going to do some minimal little things in Prolog for the assignment. The best thing that I can think of for you to do to get started with this is hit on examples. And for the examples, I clicked on these first two here. I have a knowledge base and I have lists. So if you click on, for example, knowledge base, it brings up the knowledge base. Shows you how to make some facts, shows you how to make a rule, and then it shows you how to run them. So your definition window's over here. So once you write your code, you do the same thing we did a few minutes ago. You just copy, there you go, and you turn that in as your assignment for the questions that you're answering. And so to run it, you're over here on the right-hand side of the screen, over here, and you've got your output here, you've got your input here. So for example, if I said loves Mia, so we have loves up here, Mia, and then we have X in the first find here of a match is Vincent. So there's a little button down here that says run. If we run it, we see how the results work up here. Each one of the runs shows you, let's see, actually I'm kind of curious. I'm gonna try something here real quick. Nope, okay, no, that doesn't work. In some of the interpreters, the exclamation, the semicolon forces it to continue. But it shows you each one of the outputs for each one of the runs over here. So if I want to get rid of it because I'm tired of looking at it, like I don't want to look at that error message, I click on that there. But it'll tell me each one of the runs. So if I want to get in here, let me just clean this up for you. I think I can make this, let me just click this one a little bit more. There we go. So how did I get this over here? I can do this, jealous, copy, and just stick it over here. So the examples show you how to write the queries, and it also shows you how to write the code. So jealous, we have Vincent is a member here. Vincent is jealous. If he loves more than, well, we have Vincent with Mia and Marcella with Mia. So the jealous person could be Vincent. So it's really stupid, actually. It's just showing you how to make these are the facts. If you watch the Prolog video, you'll see what a fact is. There's only two things that you can get in Prolog, a fact or a rule. The way you run the program is to run queries. So we run a query to, oh, here we go. We have next. Ah, there we go. That's what I wanted to do. We run the query to find the results. This is a top-down forward chaining system by default. So in our jealous, if we want to continue, we go next, and it'll give us all of the different instances. Otherwise, it stops at the first. So if I go back to loves X, let's do it here. We want to find out who loves Mia, and I want to get both of them in there, not just Vincent. Then I run it, and then I go next. And it tells me both of them. So it continues. So next is going to find, basically the first time you run it, it's going to find the first instance for which the question is true. In the downloaded compiler, if you're doing the Prolog, SWI Prolog on your desktop, you're going to press a semicolon in the window to get it to go. Here you just press next, and it's going to give you the next currents, which is what I was trying to do. So this, you're not going to get these buttons in the downloaded version. Not that I don't think you're going to get them in the SWI download, but you guys would do this. That basically says next, like continue working through the system. So you'll see in here, there's one also for lists. These are the examples. The list shows you some simple test programs working with a list, also demonstrating. So we have a sub list and the list, and you might recognize this from the question, one of the questions you have. In the assignment you're going to write, let me just flip over to the assignment real quick here. So this would be week 5, programming assignment number 4. And let's just stop this share and start a new one. So here we go. So this is the programming assignment number 4. These are the 2 compiler choices you have. You read through all this stuff, it kind of gives you some preliminaries, some preliminary information, yada, yada, yada. And then you get all the way down to the bottom of the assignment, and you're going to write 1, 2, 3, 5 Prolog little programs where you're going to cut and paste just like you did for scheme. So given the relations, father, mother, female, these are the facts. You're going to define a sibling, a sister, a grandson, and a descendant. And you provide the facts for the father, mother, the male, the female predicates, and then test the entire thing using Prolog. Well, that's kind of like what we did with the loads a few minutes ago. Knowing that there's no semantical reason, like nobody in Prolog knows what a father is, and you could have just said loves, actually, or mother or female. So that your definitions, don't think about this syntactically, like there's no meaning associated with these words. It's just the relation. So you're going to do a fact, and you're going to do a test of the facts for number 1. For number 2, you're going to write the relation remove an element where R is the remove is the list, and you're going to remove one instance of E from the list. Relation returns false if the E isn't a member of the list. So an element from a list you're going to remove. And then you're going to answer these questions. What are the answers for the following queries? Well, if you write the remove, ask remove A from this list, then it's going to come back with something. So you can simply just answer these, like, whatever, I'm not going to tell you, whatever it comes back with. And then for number 3, you're going to write another subsequence list. So there's a sub list. I just showed you that actually. Take a look at the list example, and you'll see something here where you're going to return true. And Prolog returns true and false. So these might be true and false, by the way. So write a relation with a subsequence to see if list 1 is a part of the list 2, and then how many different proofs are there for each of the following queries. That next button that I was showing you and the semicolon, those are proofs. How many times does the system come back with an answer if you ask for the subsequence of A and D out of A, B, D, and A? Well, if you have, if there's 2, there's 3, if there's 4, there might be an unlimited. For example, this here, the X and the Y are placeholders. It's going to come back because this can be anything, any character. This is unlimited, actually. This is going to be, do we have a B and A? We have a B and an A right here. 1 time it's going to come back. Do we have an A and a D here? Yes, we do. 1 proof. We don't have A and D following up anywhere else. So that's, and not to give you the answer, but if you're watching this video, it means you're trying to do well. So I'll give you a little hint. The answer to this question, there's 1 proof, and there's 1 proof there. There's an unlimited number of proofs there. And guess what? Same thing applies. Instead of using X and Y, we're using S. Unlimited number of proofs. So 1, 1, unlimited, unlimited. Explain why there are that many. Because there's only one way to solve each one of these two. And if you put a placeholder in here and you have an infinite number of substitutions that you can use as these variables, then you're going to have an unlimited number of solutions depending upon what happens. However, it's actually undefined. So I could say unlimited or undefined. It's unknown. It's not predictable. All right. Write a Prolog, a relation that returns a list containing the union of elements of 2 given lists, add 2 lists together, and then write something else that you'd like. Anything you want is the last question. So I'm going to flip back over to the Prolog window for a second. There it is. So in here, if you go through the examples, well, actually, if you go through the Prolog tutorial, it'll go through using Prolog, so downloading how to use the tutorial itself, the switch tutorial, managing display variable projections. It actually has reading and stuff in here too, which is actually kind of cool. In the examples themselves, if you come through here, we have movie database, where there's a little bit of text up here, but then you're looking at movie, director, actor, actresses, a bunch of data here, who stars in the movies. Always look at the bottom if you want to see the thing work, except for this one doesn't actually have any questions at the bottom. Bad example. But it should tell you somewhere. Here it is, actually. Examples. Run, movie, American Beauty, Y. Let's see who is an American Beauty. Let's see. Oh, it was the year was 1999 that American Beauty was created. So play around with this. Study the examples. There's examples for lists. There's examples for this was just a classic movie database. There's an expert system in here. There's puzzles, mortgage calculators. There's a ton of stuff in here. It's actually kind of fun. So have fun with it. This is used a lot in AI for problem solving. So you can do a lot with it. And so I encourage you to play around with it. If you take an AI class, you'll probably run into Prolog again. So, questions about Prolog before I continue? This was number 4. Nope. All right. No questions on Prolog? Okay. Let's talk about assignment number 5. Why am I talking about all this stuff today? Because we will not have a Zoom session next week. It is the 4th of July week, and I am going to be boating. I will be hopefully out on a houseboat for approximately 5 days. I will have my computer with me, and I will be able to answer questions if you need help with something. But I am taking the week off, holiday week. So you guys are going to be working solo without a Zoom meeting. The class will go on as usual. It just means I won't be holding this Zoom meeting on Wednesday of next week. I will make an announcement so you guys know that there's no Zoom meeting next week. So I'm covering all of the assignments that you're going to need. Assignment number 5 is also coming up in the schedule. And your value add for participating today or for watching the recording of this is I'm going to give you a secret assignment number 5 alternative choice. So before I get into this assignment, let me talk about the secret choice that you have. You can turn this in for assignment number 5. This is your secret alternative assignment. Write an object-oriented program in 2 different languages. So pick 2 object-oriented languages that you are familiar with. One could be, let's say, Python. The other one could be C++. Or you could use Java and C++. And write the same program twice. Something above Hello World, but any theme that you want. It does not have to be anything related to this assignment number 5. No, you don't have to use the same theme. So this means you've all taken a programming course as a prerequisite to this class, and you've all taken maybe C++. So take one of the programs that you already wrote for your C++ class when you took it, like something that does, I don't know, something simple like Fahrenheit to Celsius, temperature conversions or something. Something, you know, or guess a number between 1 and 10. So simple program that you wrote. And then write it again in a different object-oriented language. So you can recycle one of the programs from a previous class that you took. Let's say you took Java, let's say you took C++, or you took Python. Make sure it includes an object. So you have to do 2 object-oriented languages of your choice. But make sure you're creating an object, which is a class. So make sure if you're doing Java and C++, you're creating a class in C++. You're not doing C imperative style programming. You're actually creating an object class in C++. Create a class in Java. Create a class in Python. Yes, you can create a class in Python and C++. You can do any combination that you want. 2 object-oriented languages, the same program written twice in both languages. Simple? Simple. Anything above Hello World works just fine. 1 object, 1 class is the minimum you need for each one of the languages. Okay, that's your secret alternative choice. You can do that and turn it in and you'll get full credit for assignment number 5. Or you can do assignment number 5 as printed in this assignment number 5. And this is a hard assignment. Okay, so this is semantic analysis. In the first assignment, you did syntax analysis where you read a file in. Oh, by the way, you don't have to do both. Just pick one or the other. Don't turn in both. Okay. So you're going to compare, in this assignment, Java with C++. You're going to do text I/O. You're going to support data abstraction, class libraries, random number generator, exception handling, string manipulation. I don't know who in the world would do this if you were given another choice. But some people aren't going to watch this recording. Some people aren't going to show up. Some people are going to, basically just do this on their own, and more power to you. Okay. You got a scenario. I'm not going to go through the scenario. You're going to do a random sentence generator is what you're going to do by coming up with a grammar and substituting a vocabulary into it. So your task is to implement this random sentence generator in both Java and C++ and then write a comparison of the 2 languages with respect to the features mentioned in the objective section above. God, it seems like a lot of work. All right, so you're going to write this program as described above here. It's pretty, the description is pretty self-explanatory. Here's a simple grammar. You're going to plug words into it. It gives you some examples of how to do it. And then it gives you a chart down here. You're required to implement the random sentence generator class with the following methods. For Java and for C++, some of these methods are supported in Java, some of them aren't. This is why it's here. You need a constructor that passes the name of the file containing the grammar rules. You need a method called random sentence to return the random sentences from the grammar. You're going to have a toString method in Java and C++. On the other side, you're going to have to overload the cout operator, and you're going to have to create a destructor to delete the dynamic memory that's used to store the grammar. So you're going to add other methods as needed. In storing the grammar, feel free to use any abstract data type that you want, list, linked list, whatever you want to do with it. In terms of expanding the grammar, you're putting together a pseudo parse tree, actually. So you're really doing the second stage. You're doing semantic analysis in this assignment, if you do it like this, where you've got a text file that's going to have all the information in it with the grammar, vocabulary, and you're going to take it and you're going to apply semantic analysis to put together sentences, to randomly generate sentences. A lot of work, a lot of work. So your input to the program is on the command line, and you're going to input the grammar file, you're going to read it in. The output is going to be, you're going to print out the rules, and then you're going to do 3 random sentences from the grammar, and then you're going to exit. I don't know, unless you're insane, I don't think you're really going to want to do this assignment. Maybe, I don't know, some people may want to. You have no plans for the summer and you decide you're just going to make this more work. Or you're not listening to the videos or watching anything and you're just going to do it because you think you have to. But don't do this. Don't torture yourself. Don't do this unless you really, really want to. Or if you've done it already, that's fine. I totally understand. I'm not going to look at you funny if you, I'm not going to think of you differently if you do this as is. But know you have a choice, and know that if you don't want to do this assignment, you do not have to do this assignment. You can do the alternative assignment. You must turn something in for assignment number 5 though. So if you're going to do the alternative, you don't actually have to explain anything either. You just send me 2 files, a .java file and a .c++ file. And those 2 files are going to represent the object-oriented code you wrote to implement the same program twice in 2 different languages. Or send me a .py file. No explanations needed. You don't have to compare and contrast the 2 languages. You don't have to do anything. All you have to do is write the same program twice. Now, this is the assignment you're probably going to have questions about. So I'm going to open up the floor to see if you guys have any questions about assignment number 5.
Professor, I have a question. Like for the alternative choice for this assignment, can we write any function of our choice in 2 languages like C++ or Python?
When you say function, I mean you need to include at least 1 class.
Yeah.
Yeah, but you can have any functions you want or any methods inside of the class.
Okay, any methods or functions of our choice, right?
Well, you don't even have to, you can just have 1 function if you want.
Okay.
I mean, go back to like your first programming course. Maybe it was C++, I don't know. Was it C++ or Python?
Python.
Oh, okay. Did you do any object-oriented programming in Python?
Yeah.
Okay, so write one of those, take one of the programs that you wrote in object orientation and then rewrite it in another language. If you want to maybe dabble with Java, you can try Java or C++.
Okay.
It doesn't really matter how many methods there are. You don't have to use a constructor. You don't have to use a deconstructor. Obviously you can't unless you're using C++. You don't have to follow any of this assignment description at all. It's your theme of any program that you, I mean, I kill 2 birds with 1 stone. I just recycle something you already wrote.
Okay, yeah.
That's a good question. I'm glad you asked it because other people have the same question they're just not going to ask.
Okay.
How about anybody else? I'll take that down for a second and put back up the class. I can find the class. There is the class. So assignment.
Professor,
oh yeah.
Yeah, one more question. Like, so there should be like 1 function with written in Java and like another language, object-oriented language, right? So it must include the class.
What do you mean when you say function?
Like a class with like objects. Uh,
Yeah, yeah, yes,
yeah. Okay, so it must be written in two languages, just
correct.
one
The same
code, right?
program. So if I
Yeah,
gave you
yeah.
a programming assignment, I said, write this program is going to do a currency conversion, or it's going to do a, we're going to change temperatures from Fahrenheit to Celsius.
Okay.
Just any program. Just write it twice.
Okay, okay, yeah. Thank you.
Two different
Yeah,
languages. But make sure they're object-oriented languages.
yeah, sure. Thank you.
So that assignment was for actually the week after July, which is next week. So we're in week 4 right now. Week 4, you're playing around with Scheme and Lisp, and you're taking the midterm. And please do take the midterm by the end of the week. You have 7 days. You have till Sunday night to take that midterm. And then when you, next week, when we're kind of taking my vacation week, there's no Zoom meeting, so I decided to go over it as well. So we have that Prolog assignment due. So you're gonna work on Prolog next week. And then after that, I previewed for you, just in case you wanted to work ahead, the object-oriented assignments. So that's the object-oriented assignment that comes up here. After that assignment, the other 2 assignments are really easy. If you haven't looked at them yet, you'll be shocked when you see them. They're super duper easy. There's no programming involved with them. It's just reading the book and answering some questions, really. It's just textual answering questions. I will wait until I come back. We will have a Zoom meeting in week 6. We just don't have a Zoom meeting in week 5. So the week of 4th of July, maybe you guys want to enjoy your holiday week. It is a holiday. It's 4th of July in the middle of summer. So I don't know, try to enjoy the week. And then when we come back on July 6th, the week of July 6th, on the regular Wednesday meeting, I will go over probably the next assignments 6 and 7. So we're all the way through 5, gives you lots of stuff to work on in the next couple weeks. Don't wait until Sunday night at 11 p.m. to take the midterm. I see about maybe a third of the class has taken it already. So take it before Sunday night, because inevitably you'll have bad internet access or something will happen, or Blackboard will get slow or something. I mean, you're gonna have a problem. So. All right, do we have questions? Now I'm gonna open up the floor for anything. Any questions about anything you guys need any help with?
Professor, I have one more question. Yeah,
Okay.
for scheme programming assignment, like there was a second question about finding modulus of 2 numbers.
Uh-huh.
So my question is like, can we use a modulo API in our code?
Yeah, there's a function that does it for you.
Yeah, so can we use it?
You can use it.
Okay.
If you can find it, you can use it.
Okay, okay.
You can use any of the built-in functions that you'd like. You do need to figure out how to call it, but you can use it. Calling is super duper easy. It's like 1 or 2 lines of code and you can call that function. So you still want to define it. You don't want to not define the function, but you can define a function that calls another function. Does that make sense?
Yeah, thank you.
Okay. Because some people have a tendency to turn it in and they'll just write it out mod. If you put that code in there, mod, space, and put the variable, it'll run actually. So you're just going to define, I have a tendency to use an old term, it's called wrapper. A wrapper is kind of like if I run a function, it calls a function. You know, like if I create, like in C, if I created an add function, and then I created another one that said add again, and the add again function called the add function, that's what I call a wrapper. You're wrapping another function on top of a function. So that's pretty much what you're doing when you do a wrapper. Anybody else have any questions? I'll wait a few minutes. Otherwise, we're kind of done for today.
Professor, I have one more question about midterm.
Uh-huh.
Can we get any kind of like a practice quiz question so
Any
that
what?
we can
Oh,
any
practice?
practice quiz question? Yeah.
I don't have any practice questions.
Okay.
No, I don't have any practice questions. The questions are fairly straightforward, though.
Okay. Okay. So it will be like topic based, something like
Yeah,
that.
yeah.
Okay.
You know,
Okay.
like what's the
Concept.
difference between syntax and semantics? A, they're the same. B,
Okay.
syntax
Yeah.
does this, semantics does that. C, blah, blah, blah. D, none of the above.
Okay. Okay. Yeah.
Yeah. If you've done
Yeah.
the chapter readings, you'll ace it. It's pretty easy.
Okay. Okay. Thank you.
Mm-hmm. Anybody else? If not, then we are done. So today's meeting was about 45 minutes or so, which is a little bit longer. Some will be longer, some will be shorter. So I'm done. If you guys are done, we can go and finish our day. So I will, good luck on the midterm. I will see you guys next time. Not next week though. No Zoom next week. All right. Bye.